Hello, I welcome you all in this presentation related with the subject materials processing fundamentals and practical. In this particular presentation, I will be talking about the few recent advances in the field of the metal forming. So, idea behind these advances is primarily to see that how effectively, easily metal forming can be realized. So, the advances have taken place both in the field of the bulk metal forming or sheet metal forming. So, in this particular presentation various approaches which have been used to enhance the effectiveness efficiency of the metal forming approaches will be covered. So, like advancement in sheet metal and bulk metal forming includes like high temperature. So, here use of the external heating like use either induction or the laser or any other suitable heat source is used to see that how the metal can be softened, ductility can be enhanced so that the efforts required for sheet metal forming can be minimized. The incremental forming is the really recent development where the prototypes or relatively complex shape products are made with the using the sheet metals without using typical punch, and this is the incremental stepwise controlled plastic deformation which is carried out with the help of a rounded tipped tool, and the tool movement is controlled using suitable robotic system or the NC machines. Then rubber pad forming is the another one which is primarily used for making the complex shape thin sheet components where the die is used only in one side and other side rubber pad is used. Application of the rubber pad puts the uniform pressure in the sheet metal which is being deformed, and that in turn facilitates the more improved the metal forming. Thixoforming is that one typical one wherein the plastic deformation or change in shape of the metal is realized by application of the pressure in, in the metal which is in the semi solid state. Okay. So, there are two typical characteristics. Metal is in the semi solid state, means there is both liquid and solid and it tends to flow easily. So, under the pressure metal is subjected to deformed, or the shape is given in this approach in order to realize the components which are almost near net shape which is desired. So, this in turn reduces the requirement of the machining and number of stages which are required to get the final product. The electromagnetic forming is the another one wherein the electromagnetic force is used for the plastic deformation of the sheet metal. So, here what is done basically, say there is a die and the sheet metal is placed, then the electromagnetic force is applied in such a way that the sheet metal under the electromagnetic forces follows the die to produce the shape which is to be generated for making the product. Sheet metal spinning is again a kind of making the thin tubes or thin walled cup shaped components by the spinning process. So, when it is done with the help of external heat, it reduces the efforts required for metal spinning. So, we can use the friction, or we can use external heat, other means of the external heat application for reducing the yield strength and improving the ductility so that the metal spinning can be performed effectively. So, these are the basically approaches: hot or warm forming, where the sheet metal to be processed which is being held suitably, and here at these the gripping ends the sheet metal is heated. This is one. So, we can use induction heaters for this purpose, and this will be increasing the temperature of sheet metal for realizing the reduced yield strength and increased percentage elongation, and that in turn will facilitate the plastic deformation based sheet metal forming. Other than this, laser and other heat sources can also be used to increase the temperature of the sheet metal. Then thixoforming is the another approach where, like say, the metal bulk metal is taken and then it is processed in such a way that there is a partially liquid metal and partially solid metal. So, like say 30 to 40% liquid and like say 70 to 60% of the solid. So, this is realized by heating the bulk metal in the in between the liquidus and solidus at a temperature at a temperature that allows realizing this kind of the combination of the liquid and the solid. Okay. So, say here in x axis we have the alloying elements, this is say the phase diagram. So, for a particular composition, say the composition of the alloy is this. So, we will try to select that heating temperature in such a way in the between the liquidus and solidus, this is solidus. So, the temperature between the liquidus and solidus is selected in such a way that we have this side liquid and this side will have solid. So, it is selected in such a way that this temperature at which the bulk metal will be heated for realizing the like say 30 to 40% of the liquid and 60 to 70% of the solid. So, that is how we try to select, so that in the semi solid condition the metal tends to flow easily under the lower lesser force, lesser stress conditions to get the desired shape. Now, this kind of the shaping can be done in the closed die or open die. So, this is the another approach. In the incremental forming approach, what we do, like say at the ends the sheet is placed like this, and then a tool, round tipped hemispherical shaped tool is allowed to deform the sheet in controlled way stepwise. So, initially it will be working here, then here, then in here, and gradually the metal sheet will be deformed as per the shape which is desired. So, this kind of the thing will be done in steps. So, both x and y and z movement of the tool which will be working on the sheet, that is controlled either with the help of the robotic arms or with the help of CNC machine. So, it can be like single tool incremental forming or it can be double tool. So, in case of the double tool we will be using the two tools to deform the sheet metal. So, this can be done just by holding the sheet metal at the ends, or it can also be done with the help of using suitable backing plate or face plate. Okay. So, application of this backing or face plate in the lower side or in the upper side will improve the accuracy of the component that will be produced through the incremental forming. Okay. These are the few you see novel approaches apart from the other approaches about which we have talked. So, we will be trying we will be seeing the details of these and the approach of these processes in bulk metal and sheet metal forming as far as the advancement in metal forming is concerned. So, initially we will be taking up with the thixoforming. Thixoforming is a metal forming process that utilizes the semi-solid state alloy in the semi-solid state to produce the near net shape component. So, this will be requiring lesser post processing in form of the machining or the other the processes which are needed for realizing the desired size and shape. So, thixoforming involves reheating the metal alloys with the non-dendritic shape the non-dendritic microstructures into the semi-solid state with like say 30 to 40% of the liquid, and then it is formed into the final shape which can be open or closed die in order to realize the desired shape. So, metal is processed suitably to have the like non-dendritic structures, these are mostly spheroidal shape. Okay. And then this is heated to achieve the like say 30 to 50% of the liquid, and then the same this metal in semi solid state subjected to the application of the pressure to get the desired shape in suitable die which can be open or closed. This process offers the advantages like reduced resistance to the deformation, because metal is already in semi solid state, it will be showing the good the flowability. So, good the flow and the plastic deformation capability. So, good flow capacity as compared to the traditional forging processes. So, the key features of the thixoforming includes like metal is processed in semi-solid state. So, this the processing of the metal in semi-solid state leverages the unique rheological properties of the alloy in their in the semi-solid state, and where they will exhibit decreased viscosity and when it is subjected to the shear stresses. Additionally, the metal is processed in non-dendritic conditions, means the metal is having the non-dendritic structure, and that allows very good resistance for the crack nucleation, and improves the ductility, fatigue resistance, etc. So, alloys with the spheroidal microstructure formed by the methods like reheating or stir casting, which is like a specific casting techniques in the thixoforming. So, the material used having the non-dendritic structure, and the material is attained in the semi-solid state by heating it suitably in between the liquidus and the solidus temperature, and thereafter once the material is ready, then the suitable shape is given using the various approaches like thixocasting, where forming is done in the closed dies, thixoforging, forming is done in open dies, thixorolling, thixoextrusion, and thixomolding. So, the metal in semi-solid state with the non-dendritic microstructure is subjected to the pressure for realizing the desired shape in open or closed die to produce the components with almost near net shape. Okay. So, thixoforming, because of this non-dendritic feature of the products which will be produced through the thixoforming, the parts show improved mechanical properties, reduced casting defects, and near net shape geometries. So, this will be reducing the machining, this will be increasing the soundness, and improved resistance to the loads during the service in form of improved mechanical properties. So, what is done basically? The raw material is to be prepared. So, feed stock often in billet form with the desired non-dendritic microstructure is prepared. Then stock material is reheated. So, the feed stock is reheated to the appropriate temperature, so that the desired proportion of the solid and liquid state can be realized, and thereafter forming is done. So, semi-solid metal is then formed into the various shapes using suitable techniques like thixoforging or thixocasting in order to get the products. So, this process finds numerous applications in the engineering industry because of its attractive feature of the producing near net shape products, improved mechanical properties, and reduced processing, post processing for realizing the desired the dimensions. So, thixoforming is used in the industries like in automotives for producing the components with the superior mechanical properties, and it is also used in aerospace industry for processing of the metals like 7075 alloy to make the products using thixoforming. The warm forming is the another the development where the metal sheet metal is subjected to the external heat. Okay. This external heat can be applied with the help of the induction heating or with the help of the laser. So, induction heating or the laser, these will simply be reducing the yield strength and improving the ductility, which will facilitate the easy deformation and using the reduced forces. Okay. So, the induction heating or the laser can be used for the heating purpose. The laser assisted heat metal forming, in the laser assisted metal forming processes where laser is used for heating the sheet metal to be formed, and once the metal is heated, the properties become more favorable from the deformation point of view. In laser assisted spinning, for example, the metal forming zone is heated and the pressing rollers are used to deform the sheet metal. So, the focal spot of the laser is positioned directly in front of the pressing rollers to facilitate the deformation. An interesting part is like we heat the metal so that it is the temperature across the section is homogenized, and then above the upper critical temperature, this is subjected to the plastic deformation, okay, followed by the air cooling. Okay. So, the warm forming in this approach offers the many advantages because of reduced yield strength and increased percentage elongation. It offers many advantages like improved formability. Okay, in particular because the material is softened and the ductility is enhanced, and therefore this is particularly used. If the metal is already having the low yield strength and high ductility, then it can certainly be easily given the desired shape. But if the metal is of the lower formability, then this can be applied very effectively. So, the metals which show a little less formability, there the warm forming is found to be effective. Warm forming, or you can say hot forming, is found to be effective. So, improvement in formability in particular for the metals that are difficult to form. Because of the reduced yield strength, it becomes easier to deform the metal plastically. So, reduction in the forming forces which are required, and softened metal does not offer much resistance to the much resistance against the tool which is being used for the deformation purpose, and therefore reduction of the tool wear is also observed, because with the less force the metal experiences the deformation when it is heated, and therefore the tool wear is reduced. And because of the improved formability, it allows the it increases the greater geometric flexibility to realize the shape. This is an example where the sheet metal is being heated through the induction heaters when it is being held at the end. Okay, and here we are using die and punch, and then wherever the material is being supported through the die support, through the supports, it is subjected to the heating so that it can be deformed suitably. Incremental forming is the another relatively new advancement in the area of the sheet metal forming. So, this is known as incremental sheet metal forming, or ISF. Is a die-less sheet metal forming. It does not use any die or punch, it uses the simply rounded tool, okay, to deform the sheet incrementally. Okay. So, like say there is a sheet, it is being held at the ends, and then the tool will be applied, and this is the robotic control or CNC control tool that will be causing the controlled incremental stepwise plastic deformation of the sheet in order to realize the shape desired. So, this is a die-less process. This is a very important feature of this process. This die-less sheet metal forming process, where a sheet is shaped into the final form by applying small incremental deformations using a tool which is a round tipped tool, and the tool movement is controlled suitably with the help of either robot or using the CNC machines. So, this process is particularly suitable for the making prototypes and producing the products in smaller quantity of complex shape, and more also very good for making the customized products. Okay. So, as far as the steps are concerned of the incremental forming processes, this process relies on the small increments of the plastic deformation to realize the desired shape. So, incremental step forming, incremental sheet metal forming involves repeatedly deforming the sheet metal in tiny steps rather than single steps like conventional drawing or the bending, or likewise many other sheet metal processes. It uses the small steps controlled plastic deformation is small increments, okay, rather than single step involving large plastic deformation like in traditional deformation based sheet metal forming process, which is traditionally called as stamping. Okay. So, this is the key feature. Incremental small, the sheet metal is deformed in small increments and one by one. Okay, and the controlled movement of the tool, this is done in a controlled way, like sheet metal is this and the tool will be working here initially, and then so once this location is deformed, then movement will be changed, tool location will be changed, so that the tool movement is typically realized with the help of CNC or the robotic arm, and the tool is round tipped tool or a spherical shaped tool, and the path along which the plastic deformation is to be realized, that is done with the help of a computer program that generates the tool path to realize the desired shape to be achieved through the plastic deformation. And the sheet metal clamping can be done simply by holding the sheet at the end, or it can be done, sheets is typically clamped on the fixtures during the or die during the sheet metal forming. The single point incremental metal forming uses single point tool to deform the sheet, and in the 2-point incremental forming it uses the two tools like one tool here it will working and another tool will working at another location in the sheet which is to be deformed. So, this will accelerate the process of the deforming the sheets to make the products. Okay. A single point incremental forming uses only the blank holder or a forming tool with the semi spherical shape, like this is the blank holder, this is the sheet and this is the tool which will be working round tipped, and the tool will be rotated and it will be given the desired movement in the downward direction to deform the sheet. So, there are two aspects, the rotational speed of the tool is one, okay, and another is the curvilinear speed at which a tool is moved during the deformation. So, a face plate or backing plate can be used to improve the accuracy for holding the sheet, and the angular velocity of the tool, that is the tool RPM, and the tool speed in meter per minute, meter per second are the two important parameters that contribute significantly towards the ability of the sheet metal to deform and produce the complex shape. This in turn helps in realizing the desired high production rate. Okay. Typically, the sheet metal thickness for incremental forming is around 1. Okay. As far as the advantages and limitations are concerned of the incremental sheet metal forming, it does not involve die and the punch to give the desired shape to the sheet metal. So, it reduces the tooling cost because it does not require expensive dies, rapid prototyping because it can be used to quickly produce and iterate the designs while the product is still in the development stage, and it allows the customization easily create the unique shapes and features, and it is suitable for small batches, okay, and a smaller quantity with the specialized part or unique shapes. As far as the limitations are concerned, the process is slower than the traditional method because the desired shape in traditional method is realized in one go, while in incremental forming it will be done in a number of steps and it will be time consuming. So, incremental nature of the process can be slower than the traditional stamping, and there is a potential for a spring back. So, sheet metal may spring back after the deformation, and therefore, it may compromise with the accuracy of the products which is produced. This may require the adjustments to produce the things as per the requirements, and the work hardening sheet metals can become progressively harder with each deformation, and that will can limit the forming thing. So, formability can be limited with this kind of process. As far as application is concerned, incremental sheet forming finds application in many industries like automotive, aerospace, medical, for prototyping, for low volume production and for customization purpose. That will help in producing the unique shape, unique feature product in smaller quantity. Flexible forming is this one typical example of rubber pad forming is belongs to one category which is known as flexible forming. In rubber pad forming, we use rubber and one die with the desired features, okay, and in between the rubber pad and the die, what we do, sheet metal is placed, then the die is pressed onto the sheet metal. So, rubber pad will be applying the uniform pressure in the sheet metal, and the pressure coming from the die side will deform the sheet metal according to the shape of the die which is to be produced, and at the end we get the product which is to be made. So, rubber will be applying the uniform pressure in the sheet metal which is being deformed, and therefore, formability is enhanced with the rubber pad forming is used. So, rubber pad forming is a metal working process that uses the rubber pad and the rigid die to shape the sheet metal into the various form as per the requirement, and the sheet metal is pressed between the die and the rubber pad, permitting the rubber to conform the die shape and mold the metal accordingly, and the process is particularly useful for forming the thin sheets and is commonly used in industries like the aerospace, automobile and electronics, especially where the thin sheet is to be processed for realizing a particular shape. As far as the steps are concerned of the rubber pad forming, like it uses a setup having the rigid die and the rubber pad, okay, which is made of the particular kind of the rubber, and the sheet metal is placed between the rubber pad and the die, and then pressure is applied from the die. So, pressure is applied from the die, forcing the rubber pad and the sheet metal into contact with the metal to come in contact with the die and then cause the plastic deformation. Rubber pad being compliant and distributes with the pressure evenly, permitting the sheet metal to confirm the shape of the die, and at the end sheet metal is shaped into the desired form, producing the part with the smooth and the desired surface features. So, this is extremely good for thin sheets, okay, and you need to prepare the die from one side, another side we are using the rubber pad. So, rubber pad will be applying the uniform pressure when the sheet metal is pressed or force is applied with the help of die, so that the sheet metal takes the shape of the die, while the pressure will be applied uniformly from the rubber side. So, that in turn will be helping to enhance the formability. Okay. So, reduced tooling cost because only one rigid die is needed, simplifying the tooling, and that in turn reduces the cost, and higher production speed. Process is relatively fast, making suitable for mass production, and complex shape can be produced because rubber pads flexibility allows the forming part with realizing the intricate geometries, and improved formability because rubber distributes the pressure evenly, promoting the better formability and minimizing the defects like cracking or fracture tendency. The rubber pad forming is extensively used in the automotive industry for forming the parts like engine components, fuel tanks, exhaust systems. Aerospace, it is used for creating the lightweight structures and intricate soft aircraft component. In electronics, it is used for manufacturing housings, enclosures and metal parts for the electronic devices. And in other fields like producing the diaphragms, cups and other metallic parts used in various industries. Electromagnetic sheet metal forming is the another advancement where electromagnetic force is used for realizing the plastic deformation of the sheet metal, and the shape of the die allows when the force is applied, the sheet deforms and follows the shape of the die in order to produce the component as per the requirement. Okay. So, this is the idea. So, in electromagnetic forming, it is a kind of very powerful and high speed metal forming technique where the strain rate experienced by the sheet metal is very high, 1000 to like say 10 to the 5 per second, and the deformation velocity is also very high, like 300 meter per second. So, the process is very fast, very quick, and this process is based on the use of the Lorentz force for realizing the plastic deformation as per the high strength pulse of the electromagnetic field generated during this process. Thin sheet metal is accelerated to very high velocity in a very short time of few milliseconds. So, this process is like this is the coil that will be generating the high electromagnetic Lorentz force onto the sheet, and this is the die. Okay. And when the force is applied, sheet is pushed against the die and takes the shape accordingly. So, like say this is the sheet and this is the die and the force is applied. So, it will be taking the shape gradually in as per the shape of the mold to make the components as per the mold or the die geometry. Okay. During the electromagnetic application of the force, very high electric current pulse is used. It is passed through the conductive coil and by discharging a capacitor which generates the high force, okay, onto the sheet metal, and it pushes the sheet metal at very high speed with high force against the mold or die, and which forces the sheet metal to get deformed. Okay. So, the electric current produces the transient electromagnetic field or magnetic field around the coil, induces the eddy currents in the sheet metal to facilitate the movement of the sheet metal against the mold for plastic deformation. Since there is no physical contact, there is no lubrication, there is no mechanical contact with the workpiece, there is no lubrication, process is environment friendly, only electromagnetic force is generated where sheet metal is pushed hard against the die in order to take the shape. It allows the high formability limits, high controllability and repeatability of the process, and a significant increase in the workpiece ductility as compared to that of the conventional, and uniform strain distribution and good surface quality. So, there are many benefits which are realized through the electromagnetic forming. Sheet metal spinning is the another one, like say in the sheet metal spinning, what is done, workpiece is held, this is the workpiece sheet metal, Okay, this is the, you can say, this is the mold or the die against which the sheet metal is held, and then the tool is pressed against the tool in form of the roller is pressed against the sheet metal, and then it is moved. Okay, so shear spinning is the process combining the conventional spinning with the coupled with the simultaneous intensive thinning of the wall. Like say initially thickness is more, but after this spinning, this is thickness is reduced significantly while it is taking the shape of the cup. So, shear spinning is applied to the disc, spinning is applied to the disc or draw force from which the cylindrical, conical or curvilinear shape with the thick bottom and the thin walls kind of the products are obtained. Unit pressure in the shear spinning is very high to the tune of the 3000 MPa, and this process parameters in the process parameter of the shear spinning includes like circumferential speed reaching up to the 5 meter per second, and the feed rate is in the range of 0.01 to 0.25 mm per revolution. Okay, finished components are formed by shear spinning is characterized by smooth surface, increased mechanical properties due to the work hardening. Okay, so when the metal is subjected to the plastic deformation, this will be experiencing the work hardening, and that in turn will be helping to enhance the strength of the metal. But sometimes the ease of the deformation is not very good, then we can use the external heat to soften the metal, reduce the strength and improve the ductility. So, we can use hot air or the flame or the laser beam. So, hot air, the spinning is done in the hot air chamber, and so that the metal is softened, and then roller will be doing its job for sheet metal spinning. So, this heating improves the formability and reduces the work hardening effect, and therefore, it is found very suitable for magnesium, nickel and titanium sheets, and this allows the improved quality due to the limited thermomechanical damage to the metal, and it requires reduced forces for spinning due to the improved formability of the material. Now, I will be summarizing this presentation. In this presentation, basically I have talked about the few recent advances in the field of the metal forming, both bulk metal forming and sheet metal forming, and I have talked about the basic approaches which are used in thixoforming, worm forming, metal spinning, electromagnetic forming, increment forming, etc. Thank you for your attention.